Thank you for getting up so early to attend my session, and also, of course, for a fun-filled day at JFOL. So the name of the session is Spice Up Asciidoctor Documentation with Java, and I think one of the things as developers, at least for me as well, it counts. Documentation is mostly an afterthought on your project. So if you're writing code writing is fun, you write your tests, and then at the end you have to write your documentation, and that's something you probably don't want to do, and it has something to do maybe with tooling you have to use. I've been on projects where I have to use, for example, Microsoft Word to write my documentation. That's no fun at all. Or you have to use, for example, Confluence, which makes it even difficult to write code or to write your documentation in. So what would it be nice if we have a solution to have the documentation within our code base? We can check it into Git, it's text-based, we use a markup, and even can extend it with Java, and that's what this session is about. So we can use Asciidoctor documentation and extend it with Java, which is pretty nice. So a bit about myself. My name is Hubert Klein, Ikkink, also known as Mr. Haki at Twitter, for example. I have my own website, I have a blog. I work at a company called J-Driven, which is based in Nieuwegein, which is a consultancy company with a lot of Java specialists that do a lot of projects. So the agenda for today, it's actually a small introduction to Asciidoctor for people that don't know Asciidoctor yet, a bit of the markup that can be used. Then we're going to take a look at Asciidoctor J, which is actually a port of Asciidoctor into the Java space, so we can run it on the JVM. We're going to take a look at how the transformation process works. So if you write your documentation in Asciidoctor, what does the tooling do and what will the output be? And then the nice thing, and that's what really the main point of this talk, is extensions. So in that process of transformations, we can extend Asciidoctor J and write our own extensions to make customized code in the transformation process. And we will end hopefully with some examples, and let's see how far we can get. Asciidoctor itself. If you look at Asciidoctor, which actually a tooling which takes markup documentation, which is written using AsciiDoc markup, which is a standard. If you know, for example, Markdown, Markdown has a lot of flavors and different extensions on it. AsciiDoc is more of a standard, this standard way of how to define your markup. And what Asciidoctor did actually is use that AsciiDoc markup and provide tooling to transform it in, for example, HTML, and also provide some extensions to the AsciiDoc markup. So, for example, we can include source files and stuff like that in our generated documentation. The thing is, Asciidoctor itself is written in Ruby. So if you install Asciidoctor, actually you install a Ruby gem on your machine, but that means that you need Ruby and you need to install the Ruby gem. And as this is a JFOL, a Java conference, it would be nice if we can also run this, of course, on the JVM. And that is where Asciidoctor J comes in. Asciidoctor J is actually a port of Asciidoctor to the JVM. And what they did is they included JRuby. And JRuby is the Ruby implementation on JVM. And in that way, they allowed us to write Java code. And under the hood, it uses JRuby for running all the Asciidoctor things we need. But we don't need to be bothered with it. We just include an Asciidoctor J dependency in our project, and we're ready to go. So if we kind of take a look, for example, at some of the, where is my code? This is it. And then, okay, this one go. A bit of Asciidoc markup that is supported by Asciidoctor and Asciidoctor J. So what you can see, for example, we can have different sections in the documentation, and that's actually started with an equal sign. The more equal signs you have, the deeper the nesting is of levels of the sections. Also a nice thing about Asciidoc markup is we can include the document attributes, which is document variables. So our document is already a kind of code where we can include variables that determine how the output will be. So for example, I included here a document variable called icons, and it has the value font. And that means that we can have this nice little light bulb here, which is a font awesome icon actually that is generated. If I would move that, it will be an image that would be downloaded from the internet, for example. I can also have my custom document attributes. In this case, it's conference, and it has a value JFOL 2022. And you can even use it as a variable reference in your Asciidoctor markup. So using curly braces, you can see it here at the top. I can reference any document attribute that is defined inside in my document. Also, documentation can have comments in Asciidoctor markup, which also feels a bit like code. So when I, for example, uncomment the TOC, so table of contents document property, automatically a table of contents section will be in the output that is generated. Yeah, for the rest, if you know Markdown, a lot of the things that can be look kind of the same. So if you want to have italics, then you can use underscores. If you use asterisks, you get bold output. If you use backticks, you get code output. You can have lists. There are things that are called admonitions in Asciidoctor markup, which kind of wants that you have certain text stand out in your flow of your documentation. And for example, there's note, there's tip, there is also warning. And you can also see it automatically changes here, which is kind of nice if you write Asciidoctor markup and you have IntelliJ. The IntelliJ plugin is pretty nice, so that works quite well. We can also have blocks, and actually blocks are blocks of documentation you have that have special meaning. So in this case, we have a quote block. It's we use the quote here as the name of the block. It can have several attributes that can be used, and it will have a different output if needed. The nice thing is these kind of blocks we can also write ourselves. So if something is not included in Asciidoctor markup or in Asciidoctor, we can write it ourselves. Or you can download a dependency, include it, and if somebody else wrote an extension, you can use it as well. Also a nice feature, and that's especially nice if you write documentation for developers based on code that you have in your project, is the inclusion of source code. Actually, you can include any source file you want in your project. So in this case, I have this include colon part, which means I want to include a file, followed by the file name. So there is in my directory a file called app.java, and you can see on the right the contents of the file because it's included. But it's not part of my documentation in the sense it was part of the generated output, but it's not part of the documentation when I write it. I just reference the file. And you can imagine if you want to reference source files in your documentation, if you write proper tests, you know that the source file in your documentation is properly tested and it will work. It's not something you copy-paste from something a couple of months ago. You have to keep up. If you change it, it will automatically update it in the generated documentation, which is pretty nice. Also, I have shown here that's something called callouts. So you can have special comments in your source file and reference it beneath here using the brackets, and then it has a nice output. And also, one of the things I like in Asciidoctor markup is the way you define tables. You don't have to do any ASCII art thing like draw the table with all the pipe symbols or whatever. It's just definition of a table. It starts with a pipe symbol and 3 equal signs, and that's also the end part. And anything in between will be table cells and table rows. And by default, the first one is the table row, and it also has already different output. You can see it on the right. And then for each cell, it's just a pipe symbol and the text you want to include. So, was anybody not yet aware of Asciidoctor markup yet? Okay. So hopefully it's a very quick introduction, but it kind of shows the nice features that Asciidoctor has and that we can use when we generate documentation. So the other thing I want to show, if you have Asciidoctor J, so the port of Asciidoctor to the JVM, the way you can install it is actually quite easy. There is, if you use it, SDKman, and you can just install Asciidoctor J, and it will be installed on your machine. It will be available on the path, and I already did that, so I can just go Asciidoctor J. Is this one readable? So it's just running on my machine now as a JVM application. I can do the help to see what all kind of things I can do, but it has the same features as Asciidoctor itself has. And what, for example, I can do Asciidoctor J, and I can convert my sample documentation we just saw. Quite simple. And when I open it, I can see the generated HTML. There we go. So what we just, this is bright in the early morning, just to wake you up, right? So what we saw now, the markup, in the end, when we use the Asciidoctor J tooling, this will be the default generated HTML. We can customize it if we want to, but this is what you get out of the box, which is already pretty nice. You can see the similarities between the preview we had in IntelliJ and the generated documentation, so that's also quite nice. And that's really the way we can work with the documentation. I'm only focusing today actually on the HTML output that's generated, but you have to know that we can also generate PDF output from our source document. Just there is also an Asciidoctor J PDF tool, for example. And you can also use DocBook, which is supported. And from DocBook, you can also go to all other kind of formats. And there are also third-party conversion and converter processes that also, for example, convert it to Word, LibreOffice, and stuff like that. But today I will focus on the HTML part. So like I mentioned before, let's see where there it is. So we have this command line interface, just install the software, and you can run it on any documentation you already wrote in the Asciidoc markup. The nice thing is, because Asciidoctor J runs on JVM, we can also use it in Maven and Gradle and any other build tool that runs on JVM. And luckily for us, people wrote already a Maven plugin for it. People wrote already a Gradle plugin for it. So if you use one of those build tools, it's just very easy to include it in your build process. So just include the source files in your project, configure the plugins correctly, and in the end, you will have generated output also part of your build process. And that will be the documentation of your code. The other nice thing is what I mentioned before, Asciidoctor J. It's not only a command line tool, it's also a dependency. So if you include this as dependency in your project, you can use the same Asciidoctor J things we saw before, like converting documents, in your Java code. So let's see how that works. Let's go to the correct one. So first I will show in this case I've built a project that is a Gradle project. For people that don't know Gradle, but this is the most important part. Actually, only this line is the most important part. This is defining your dependencies for your project. So in this case, I want a dependency, and it's the group name is org.asciidoctor. The artifact ID is actually Asciidoctor J, and the latest version is 257. All the other stuff you can see is used for the demo. That's something we use, but that's not something you have to use if you use Asciidoctor in your project. So let's see what happens if we want to do the stuff from our Java code. So in this case, what we actually need to do, this is just a simple main application class, to get access to our Asciidoc instance. And luckily for us, there is a factory class also that creates an Asciidoctor instance. And because it's also auto-closable, I put it in a try block, so it's automatically closed at the end. But the Asciidoctor instance I have now already provides me with a lot of options and methods to also convert documentation. So for example, what we saw in the command line, where we just say Asciidoctor J followed by the file name of the thing we want to convert, we can also just use Java methods for that as well. So for example, I do have a sample a doc file. And the second argument is actually a list of options I can provide. And luckily, there's also a builder implementation, so I can do things like save mode and save. This save mode and save is actually needed because I include external files. And I know it's on my local system, and I believe it works, but that's the nice thing. I can also define a backend, for example. I can also define attributes. So what we saw before, document attributes using the colon document syntax. So we, for example, had the colon conference colon at the version. You can also inject document attributes from the outside when you build or convert your document. And also there we have a builder. And I can just say there's an attribute, conference, I will just call it the same. And there's a build. And I need to do build here. There we go. So actually one method, convert file, provide a file name, provide a set of options, and when I run this, it will run the Java application, it will invoke Asciidoctor and then do the convert file, and it has now generated the file. If you don't believe it, I will just remove the old file that was generated by the CLI, right? So let's do it again. And I can do, again, look at the source file that was generated. As I mentioned before, HTML is not the only output format. If you look quickly at my list of dependency, I also included the PDF dependency of Asciidoctor.j. So wouldn't it be nice if I just have backend PDF and then generate it? Let's see if it works. Takes a bit longer than generating HTML. And the magic happened. So let's see. And there is my documentation in PDF. So I had the same source file, in this case, generated both HTML and PDF, and it's just simply changing a backend property actually for the options you provide, which is pretty powerful. Instead of converting files, we also have an option, for example, to convert strings. You can imagine that in your code, maybe you want to use Asciidoc as a templating language or something, and that can also, of course, be done. And then instead of using convert file, we have a convert option here. And I can say, for example, I deleted too much, but that's okay. Then I have the same options I can provide. Options, build. Thank you. And I will also want to provide, of course, the variable of conference, the document attribute. So there's attributes. There's the builder, and I can set the attribute conference. Just make it a bit different. And we'll see if I can run it now. Of course it will run, but the output of convert, what we saw before, the convert file had a void, actually, so it generates the file. In this case, I will have a string, which will be the result of the transformation. And if you want to see something, I will just print it out here and then run it. And you can see at the bottom, it now generated the HTML of my little Asciidoc markup part. So it automatically turned it into a paragraph, and it also works when I want to have a bold hello, for example. That also works because it's just Asciidoc markup. I mean, Asciidoctor.j doesn't care if it comes from a file or it comes from a string or whatever. It just uses that as an input and applies all the transformation it needs to do. One final thing I want to show is that instead of converting stuff, Asciidoctor.j also allows you to look into your documentation, how it's built up. So, for example, there's a document object, and I can use load. There's also load based on the string, and there's also load file. I will use my same file, which is simple, adoc. And there is the build option. In this case, I have a document object, and that contains actually the structure of my documentation. So what we saw before, the Asciidoc markup we wrote, when you look at it, it's just text. But what Asciidoctor.j does, it parses it, and actually internally builds up a abstract syntax tree of it, so an AST. And we can also look into that AST and, for example, print out what the document title is. So we can say document title. We have a document object. And you can already see we have a lot of options to get data out of our document that is now parsed already. In this case, I will do simply a title and send it to the system out print line. And you can now see here at the bottom, document title, sample Asciidoctor for JFall 2022. So you also notice the title in my sample documentation contained a attribute. So we use the curly braces conference. Once it's parsed, it's already filled in. And when we look at what the structure is of a document, it's already filled in for us, and we can just request it. So it shows it's pretty easy to just include Asciidoctor.j in your project. Let's see what more we can do with Asciidoctor.j to make things interesting. So how does the transformation process actually work, both for Asciidoctor and Asciidoctor.j? It's roughly 3 steps. So you have your source, which is either a string or a file on your system. and it's been parsed by Asciidoctor. And it's parsed into an abstract syntax tree, like I mentioned before. It's like the AST, which is the structure of your document. So it knows, for example, there's a title, there's section, the level of the section, if there are tables, if there are cells, and stuff like that. The next step is actually processing the AST. That means looking for errors, if there are errors in the AST. Maybe even extending stuff to it. For example, the table of contents we saw before, that is generated actually in the process step, because there Asciidoctor has all the information about your document. It can just traverse it and build up a table of contents if you want to, for example. And the last phase is actually generating output. And the generating output phase, for now, today we see the HTML output. We already saw the PDF, but there are also different ways you can plug into that, but we're not going to cover that today. We're going to focus mostly on the parse and the before the output is generated part, because that's where extensions happens. A bit of the AST, very simple example. So on the left, there is the markup, the Asciidoctor markup we have. So we have a sample, which is the title of our document. There is a first section, which is called welcome, which is actually at level 1. And then there's a paragraph. And on the right, you can see the naming used in Asciidoctor, how the AST is actually built up. So we have a document, there's a section, and this is just the name. It also has different properties, like it knows that it's level 1. If you have deeper nested levels of sections, we also can request that as well. And we have all kind of blocks that are available. So there are there are 8 points where you can just write code to be part of that process of transformations. And we can actually be part of the parsing of the document, and we can be part of the output generation in the transformation process. So when we look at the extensions we can write, where we can just plug into the process of parsing the documentation in Asciidoctor J, we have 5 points. The first one is the preprocessor. That is actually when the source code is first read. So the source code is read, Asciidoctor J will parse it, and when we write a preprocessor, put it on the class path, that preprocessor will also be part of the parsing of the document, which can be useful, for example, to add extra document properties to the document that can be used later on in the output if you want to. You can just change certain things in the parsing that you want to be applied. Then there's the include processor. I already showed you in the sample of the markup I showed that there is a possibility to include external source files. The default one is just include a file, but we can also write our own include logic. So for example, if we want to include something from an RSS feed or include something from another source, we write an include processor, add it to the class path, and it will be used, and we can just also use it in Asciidoctor markup. So we can just extend Asciidoctor markup with our own things we want. Then there's a block processor. The block processor is something that is being encountered if you use the square brackets in this case with a block name. I showed you in the sample documentation, the quote, for example, that was there, is also a block, and that's quote block processor is already part of Asciidoctor J, but if you want something new, you can add it yourself. Then there's the block macro processor, which has a different syntax actually. That's the block name followed by 2 colons and square brackets, which is actually a way of defining attributes for your processor if you want to, which also applies actually for the include part. We can see that in the demo. Then there's the tree processor, which is also at the latest part of the parsing. So everything is already parsed. There is already an AST. And the tree processor allows you to go through the tree, add stuff, remove stuff if you want to. It's just very powerful to just change anything before it's actually processed again by Asciidoctor. The other 3 ways we can extend is in the generation phase. And the nice one is that's not really output dependent, but can be, is the inline macro processor. Mostly if you write code, the blocks, it's just blocks. If you have a sentence or a paragraph, and within that paragraph you want to reference something that's not yet included, it can be an inline macro processor. The syntax inline, 1 colon, and then an option of having attributes. Then there's a doc.info processor, which is if you generate HTML output, has the possibility to add code to the head section of the HTML or to the footer section of the HTML, which is actually anything after the body that can be included. That's really get specific on the output you want to have in your documentation. So we can see the HTML output. You can inject HTML or JavaScript, for example, there in the generated documentation to make things happen. And finally, we started with a pre-processor, so we end with a post-processor. And that's when the output is actually generated and ready to written to file or to an output stream, whatever. You can still have a point where you can just add something else if you want to, which is not part of a footer or a header. So let's see if we can write some of those processors and see if we can make it happen. What I want to do is first write an include macro processor, which actually, do I have an example? I can write an example. Let's do it here. I want to have something that supports, for example, follow me. This would be Asciidoctor code, and it would be like so when I write Asciidoctor code, follow me at Mastodon Mr. Haki with square brackets, so there are no attributes in this case. I want this to be transformed into a link where people can click on it and it will go to the page on Mastodon where my actually profile is. So I want to achieve this. Let's write a class, and it's called Mastodon. Processor. Add to the file, make this a bit bigger. I will move this. So what Asciidoctor, by including the dependency, it also includes a lot of, for each processor, actually a base class. When we extend the base class for each of those processors, we already get a ton of methods that we can use. And we don't have to implement lot, only one method, that's the nice thing. So we have an inline macro processor. You can already see it's importing it from the Asciidoctor extension package. And when we extend this class, we have to implement a method, in this case only one. It's a process. So when we put this into the transformation process of Asciidoctor J, and Asciidoctor will find that markup that says Mastodon : followed by something else, it will just come into this code. So what we want to do is actually transform this into a new output. So we have this Mastodon : Mr. Haki that needs to be actually a link. And how to create a link, there are different ways to do it. And also we can already see by extending this inline macro processor class, we have a lot of options to create actual logs, lists, sections, tables, just from the Java code. For our example, we need actually a phrase node, which is a special case because it's inline. And we need it here. So the first argument is actually a parent, so it will be included in the paragraph it's part of. Then we need to define the type we want to have. It's in this case an anchor. You have to look up in the documentation all the different contexts you can use, but trust me, you need an anchor in this one because we have a link. What else do we need to provide? A text. So it's actually that's what's visible on the screen. And then finally some attributes, and there is an option part. Let's say I want to have string the username, which is actually the target. So remember, this was the definition of the inline macro I want to do. This part, so after the colon and up until the list of attributes, that's the target that will be set here as the value of the target variable. So that will be, in this case, Mr. Haki, right? And I want to have here the link. So let's say it's, I'll provide attributes. And also have to provide actually an options, and that should be a list of options that are actually make sense in the case of an anchor. So one of the things we need to provide is a type, and it's actually a link. And we also have to provide a, I think it's target. And that should be the actual link. So I will just put it here. And that will be, for example, That's the server name, right? So that will be HTTPS Mastodon line at username. So we provide an option object. We make an anchor. We have a text. Now we need to make sure that there is a name, so that can be recognized as the implementation of the inline macro Mastodon. And now we can write a test and see if it works. So why not write a test? In this case, it's actually simply a unit test. That's part of the project. What I first need to do is I have this macro processor, and I need to provide it to Asciidoctor J as an implementation of that code I want to have. So it needs to be registered. So there is, of course, there's luckily a Java extension registry. Also, it's quite nice. If it's still there, there is a... Yeah, there's also a Ruby extension registry. Remember, I said before, Asciidoctor comes from Ruby world, and there are already out there a lot of extensions written in Ruby. If you have the Ruby file itself, you can just also include it. It will be executed for you. But because this is Java, I will not write it Ruby code and just do the Java part. But it has an option, right? So if you don't want to write it or port it to Java and you have the original extension written in Ruby, you can also just include it as well. So we have an extension registry, and then we can just say there is an inline macro, and my implementation class is Mastodon processor.class. So now it should be possible if I have code a markup with this Mastodon part in it, and I have it registered as an extension, it should generate the output I want. So let's do converted text. So let's do a sample. And then, sorry? Yes, thank you. I need more coffee, maybe. That's, I did something I typed a lot wrong, so let's see if it works. Or did I forget something? No, it works. So you can now see at the bottom that generated the paragraph, and you can see it now has a link. So it now links to my account on Mastodon. And the text you can see, it's the @Mr. Haakje part. Which is nice, but if you know Mastodon, it's a federated universe where it's part of actually. So when you register at Mastodon, you have to choose which server you have to register on. Now in my code, I have this hard-coded value of mastodon.online. Maybe I want to have this as a variable that can be part of, for example, the attribute list here. So everything between square brackets can be attributes to the implementation of my processor. So let's say I want to change this into, there we go, to social. And what I want actually is if this value is filled, it should actually get that value and use that in a generated output. So how do I get this value? When you look at the list of input arguments, the last one, attributes, will have the value of server because that's the one we used, right? So I can just say attributes get or default, or just get. Could be nice to have also default. First is the server, that's the name we just used. And then let's default back to, so when it's not provided, it will be Mastodon online. Otherwise, it will use the value of what we provided as an attribute to the documentation. Now add it here as well. So it will now have a server part. Now it makes sense, right? Let's run the test again. And now you can see in the output the link. The href part of the link now points to mastodon.social because that's what we provided as attribute value. If we would leave that part out again, it would just revert back to the default, which is mastodon.online. A nice tip also is just by providing attributes via this way to the specific implementation of the code. We can also, for example, get the attributes defined at a document level or are provided from the outside if you want to change that. So that would be, if we want to get to that part, just want to show it. You do get document, get attributes, and then we can do get or default, and then we'll get the attributes from the document level. So that's a higher level than the one that we provide just specifically for this macro, but it will be in a higher level, and we can also use it in our processor, which is also pretty nice. And if you're familiar with Asciidoc before, you might see also code like this. So the list of attributes, it can have names, attributes, but it can also be what they call positional attributes. So the position of the attribute in the attribute list determines actually what the attribute is. I prefer named versions because that's more readable, but some people just want to do it at position. Luckily, we can just support that as well, and we have to provide an annotation. So in this case, we have positional attributes. In this case, I have only one. And the position in this list also determines the position in the attribute list and how it's mapped to an attribute name. In our example, we only have one attribute, and it will be mapped to the server attribute name. I will just leave the code here as it is, because I already requested the server attribute value for it, and when I run the code, it should still work. Did I change something? Oh, yeah, I changed to online, so that makes sense. Yeah. So it's now mastodon.online again. This is nice for testing. You can write your processor code, write a test, use the Asciidoctor.java extension registry and register the implementation, and then simply try the stuff you want to do. You can write tests for example, you can write assertions on that the link that's generated is correctly. But when you also want to do is actually maybe is write a library with all kind of processors you have written that extend Asciidoctor and make it part of the Asciidoctor J command line. So it can be used also by other tools. In that case, we don't want to have this line Asciidoctor Java extension. Well, we do, but we want to do it at a different place. So what we can do is write a extension registry implementation. And that allows us to register our class on a higher level. So let's do it also here. And then we need to implement an extension registry interface, which is a register method. And I can just paste it here. So the register method will get the Asciidoctor instance that is part of the transformation process. And we can just use the same code, get the Java extension registry, include a macro, and it will be part of our class path. Mostly, but we have to do one more thing. Add it to the file here. So in your class path, there should be a meta-inf directory with a service directory with a file called org.asciidoctor.jruby.extension.spi.extension registry. And it includes the file class names of actually the implementation of that extension registry. When I run my test, remember I removed that code from my test, but now it's still part of my class path because I implemented it using the extension registry, and it still works. And it would also, of course, be nice if we can just create a jar file of this project. And let's see if we have something here. Yeah, so we have now a demo jar. The demo jar contains the implementation of my processor. It contains the meta-inf services part. And it should now already be enough to use it in my command line tooling, for example, or in my build tooling by extending my class path for the Asciidoctor J runtime. Do I have an example? Let's see if this one works. Yeah. So in this case, I have a simple Asciidoctor markup. And most importantly is the line here, where I reference my inline macro, and I want to have this processed outside of my IntelliJ, so I can do Asciidoctor J asciidoctor.j and have a class path and add build libs demo. And I put my mastodon ADOC file. There we go. And I can open it. And you can now see it generated this link. And it's even a fully functional link where you can just go and click on it. So that's just the way to write extensions. I only have shown now one way of one of the processors you can implement. I remember that for 8, so there are a lot of other options, which I will include in a repository and share with you the link today or tomorrow. So if you keep an eye on it, you can see it, where you can see different implementations. Also, I can show you one more thing, maybe. Where is it? Which is an implementation of actually a include processor, which is a bit different than the other ones because we have to implement 2 methods, the handles method and the process method. What the handles method does, you can see actually it determines which part you want this implementation support. So you can see here the syntax, include, : RSS. And there is the brackets again, which are the attributes for the processor, just the same way. 2 attributes, one is the feed URL and one is the entries, which is actually the number of entries you want in your output. So by just implementing the handles method, we just say, okay, if you include : RSS is in your source code, this is the code that implements the logic to replace that with something that we want. And the something that we want, you can see here. We've seen before, for example, with the inline macro, but also block macro, you can see it in block processors. You generate new blocks. So you just say create block, you create a listing, or you create something else. This is at a different level, the include processor. You have a reader object, but the reader object allows you to also push stuff again into the reader. So there is a push include method, which simply says actually include : RSS, replace that with something I want to replace it with, and it will just be used in the reader again in the parsing process for Asciidoctor. And the interesting part is there's a content, that's the most important part, that's we need to generate. I used Roam, which is a open source RSS feed reader in Java. What we can do, we can read the feed. What we do here, which is nice to know, this is part of the parse process, remember? So there's no AST yet. So we are allowed to just include Asciidoc markup as well. It will be parsed later on into the AST in this process. So this little thing here where we do content.append, this is also Asciidoc. Like the asterisk sign will make this a list. There is a link, which is a URL. There are square brackets, which is the text you want to have in the page. And then it will be replaced. And the thing is, if you run this, for example, you can this. So very easy to just extend Asciidoctor with other content you want to include in your source file as well. Maybe you can come up with other ideas, but that's a really easy way to do it. Then one final thing, where is my part here? What I've shown now is to write your own code, but there are also already Asciidoctor extensions out there in the wild that are written by other people and other library authors, which is also very useful to look at. What we saw before, we created the jar file with the correct implementation and an extension registry, and it is part of your build or your transformation process. Other people also wrote that kind of jar file, so just by including this into your class path when you run Asciidoctor.j, it's available for you. So the syntax these extensions provide can be used. And a very powerful one is Asciidoctor diagram, which is simply a dependency you include. And it allows you, for example, if you know, for example, plant UML or other text-based things that turn into graphics, then it can be used by Asciidoctor. And just include the extension, have the plant UML in your markup, and that part will be replaced by a graphical representation of that markup, which is very powerful. It also has, for example, its own block macro macros where you can just reference external files. You don't have to include even in your markup. Another one which is pretty nice, which you maybe can remember from if you look at documentation, especially about the frameworks where code snippets are in multiple languages. For example, you have this example documentation and it says in Java it looks like this, then you click on a tab, it looks in Groovy like this, in Kotlin like this, in another language like that. That's a tabbed code blocks extension that can be used. Just include it, include the two parts of the source file in your, and it can be external in your documentation. And in the output, it will generate the tabs for you and logic that when you click on it, it shows the correct stuff, for example. Another one is pretty nice is for, if you write the Java document, use it for your Java projects, the Java API doclinks extension, which actually looks through your source code if it finds in backticks a Java class name, and will try to turn that into a link to the API doc, which is also pretty nice. And finally, I mentioned here, but there are more, this is pretty nice, is a screenshot extension, which allows you to have URLs that will be automatically screenshotted and put in your documentation. So if you want to have more level high user documentation, for example, you can even have scripted. So it just does certain stuff and then makes a screenshot and put it in the documentation. It's also very powerful. So it's almost time for the main session. Are there any questions? Are you going to use it? Yay! All right, thank you for your attention. Enjoy the day in JFol. And keep an eye on my Twitter or Mastodon, and I will post a link to probably GitLab with all the examples that are not shown today. So, yeah, thank you. Enjoy the day.